So this is what we're doing today. We're going to finish up exponential and logarithmic equations, and if we have time, we'll go back to the log functions and other bases. That's less important than finishing up the other part. Today you have due Unit 7 on exponential functions, and maybe we might go through a couple of those problems too, since who has actually finished that homework?
Oh,
I have 3 left.
Okay.
I have 4 left.
So you might, would you find a little bit of review of that helpful, or are you feeling pretty okay with it?
The ones I skipped were the graphs.
Okay, so maybe we'll take a look at some of those. That might be good. And then Friday you'd have this one on logs. So that's coming up pretty soon. Which is kind of some basic ideas of logs. So maybe we'll kind of take a look at some of the homework problems there. Or I can push these back. I can push both of those back a couple days, so I can make this one due on Monday, and then I can make this one due next Wednesday. Is that better? Probably better. Since your exam isn't until, oh wait, your exam on Unit 8 is on Monday.
yeah, I think so. We had to do all the up to through
Yeah,
homework.
it's good to have
get
it done
the exam.
before the exam
Yeah.
on Monday. Right? So, I actually feel like that might be due on Sunday. I think I have this due on Sunday, if I'm not mistaken. Right, because we do have that exam on Monday. Okay, so first, let's address a couple of comments. So exam 3 needs to be on Monday. That's our last meeting day for class, our official meeting day. So if you want extra time, so there's a few people who usually like to have a little extra time beyond that hour, come at 10:30. I'll let you start early. Because at 11 o'clock, at 11 o'clock everyone else will start, but at 12 o'clock, we're going to start review of units 1 through 3. And you need to be done with that exam before that. David, so we'll talk to me, we'll work something else out a little bit. So yeah, definitely Monday at 10:30, come a little bit early if you want extra time for that exam. And then Monday at noon, we'll review units 1, 2, and 3. And then that's it for the required time. Wednesday, I'll be here, and I'll do a little review, from 11 to 12:30 on units 4 and 5. And then next Friday, not this Friday, a week from Friday, then we'll review, kind of everything. If anybody has any other questions, but we have class. Obviously, we have class today. Friday, we're going to review and prep for the exam on Monday. And then we'll have the exam on Monday. So let me talk about this part you said with difference between E and log. And we didn't have time to go through the what E is, but E is a kind of special number that comes up a lot, especially when you're doing, it's kind of this limit that you hit as you're doing different logs, which we didn't have time to go over. But the bottom line is it's kind of this unique number that comes up a lot with logs. So it's E, which I think is 2.718 something. It's just a number. It's a special unique number that, let me check this on my calculator. E, so often you'll see E on your calculator. There it is. E, 2.71828. And then it kind of goes on from there, some other numbers. But it's kind of it's kind of like pi. Pi is like this unique number that comes up pretty often in life. This is not on any of your sheets. And pi is 3.14159, right? You have pi, you've all seen pi before.
Yeah.
It's another number that comes up very often in life, right? E comes up a lot with logs. So all know like log 2 to 8. This is something you might see, right? This means the base is 2. So it means 2 to the something equals 8. Everybody on board with that part? Okay. Then we have regular log. This means the base is 10. If there's nothing written here, the base is 10. So the log in your calculator, that's log base 10. That's kind of the standard one we use. So this is the one your calculator uses. And then there's this thing called ln. ln of, I don't know, let's pick 6. This is the same thing as log base e. Base is e. So these are the same thing. ln means log base e. And it comes up so often that we made a special thing for it. So ln, it just means log base e. So when we're solving, if we look at this last sheet, we solved by taking the log of both sides. You can also take the natural log of both sides. And you get the same, and it turns out the same, because as long as you're doing the same thing to both sides. If I have, well, let's do this one. 5 equals I think of something else. Okay. This will help me do it this way. 4 plus 1. If I do the log of 5. Oh, I know. I got it. Ha. Okay. 2 to the 3rd power equals 8, right? We're good with that? Mm-hmm. Now, if I do the log of both sides, log of this, maybe I'll write it separately. Log of 2 to the 3rd equals log of 8. Now, remember that nifty trick I taught you last class? Where if you take the log of both sides, this is why we like the log of both sides, because if I have something in the exponent that I don't know, like x, for example, if I take the log of both sides, then you can take whatever's in the exponent, if you're taking the log of something, and you can move it in front. So this is the same thing as saying 3 times the log of 2 equals the log of 8. Okay, so I want everybody to bust out your calculators and find the log of 2. Hit log of 2. Do it.
So you hit 2 log or log 2?
I hit log 2. I don't know about your calculator.
Log.
You get 0.301?
Yeah.
Okay, so 3 times 0.301, and then I would find log of 8. Find log of 8. Log 8. What do you get? 0.903. And what do you know? If you multiply these together, 3 times 301, 3 times 3 is 9, 3 times 0 is 0, 3 times 1 is 3. Bam. How cool is that? right? So now, hopefully you understand that anytime you take a log of something, you can take that 3. If you're taking a log of something that has an exponent, you can move the exponent in front. We don't care if it's a 3, but it's super helpful if it's an x, because what have we learned so far? We know that you can take, if I have like 3x minus 4 equals, I don't know, 6, I can solve this for x, right? We know how to solve this for x. And now we also know if we have something like, x squared minus 2x plus 1 equals 0, we also know now we can factor this, and we know how to solve this now, because we can put it into things. We can use that factoring equation, so this becomes like x minus 1 and x minus 1 equals 0. And we know that anything, if I have something times something equaling 0, then either this is 0 or that's 0, right? So we know how to solve, we can solve for x here too, right? If you folks remember this? If you have a quadratic, you change into factors. So then we know that x minus 1 equals 0, right? People still remember that part? No?
I remember the top part, I don't remember the second part.
Okay, so there's 2 different things. So you know how to solve this one, right? But do you remember how we can factor this into this part here, doing this little x thing, right? And then once we get it like that, we can say either this equals 0 or that equals 0. Well, so that's all fine and good. The problem is sometimes we get stuff where x is in the exponent, and we don't know what that is. So this becomes a big issue for us. 3 to the what gives me 4.6? I don't know. However, I can take the log of both sides. And that lets me grab this guy, put him in front. So now I can say x times the log of 3 equals the log of 4.6. And what did we say? Did we find the log of 3 already? Didn't we just find the log of 3?
No.
Oh. What did we find the log of 2? Okay, what's the log of 3?
0.477.
0.477?
1, 2, I don't know, it goes way out.
Okay, 1, that sounds good. So x times that equals, what's the log of 4.6? So I want to find the log of 4.6.
0.6627.
6627. Great. Now, all I gotta do is divide both sides by 0.4771. Everyone take your 6627 and divide by 4771. And you get x equals what?
1.389.
1.389.
So now, if we use logs, we can solve even if 3 is in the exponent. So that's helpful. So now we know not just how to solve when x is just a linear, variable, and when it's a quadratic variable, when it's x squared, but now we can solve it when x is in the exponent. And those are kind of our 3 main things, right? Linear function, quadratic function, exponential function. So that's why logs are important. And why do we care about these in general? Because very often, we care about how much money we're going to make. So if you look at mortgages, car payments, investments, if you're investing something into a bond and you're making 5% per year, then you have an x or a time is your exponent. And you want to know how much that is. So you need to solve for how much, how many years will it take for me to earn this much money. So that's why we care, because it comes up in finance all the time. And how do you solve that? Again, if x is in your exponent, you got to take the log of both sides, which lets you grab that little x here, and move it in front. So then you can just Find this number, find that number, divide them, done. Good? So that's where this part comes in. And natural log, you can do the same thing. So say I had 2 to the third. We'll do a different one. What's another one we know that's really straightforward? 3 to the second. Everyone feel good with 3 to the second? 3 to the second is 8, 9. Sorry. Now we're going to take the natural log of both sides. So natural log of 3 to the second. I know, it's easy to do, right? Equals natural log of 9. And again, you can do the same thing. Grab the 2, throw it in front. So now we're going to say that's equal to 2 times the natural log of 3. And that's equal to the natural log of 9. So I want to find the natural log of 3.
So what do you do, second?
Oh, we just did that way. It was 0.4771.
Once we did, and I got 1.0.
Oh, it's natural log. You're right. It's different. What's the natural log of 3?
1.096. 09861.
860986.
0986.
986. So I'll go 99.
Okay.
And then what's the natural log of 9? I want to do the natural log of 9. So it's the ln, the natural log. 2 point what?
197.
2.197. Cool. Now, if we multiply 2 times 009, we'll end up with 2.198. So it's off a little bit because we rounded. Does everyone see that? It's off a tiny, tiny bit because we rounded. This was really 8.6, right? So if we didn't round, we made this 8.6, for example. We left it at 8.6. Then this would be 2.972, right? Does that sort of make sense for folks? So you can take the natural log of both sides of something, and they'll still be the same. And again, you still have that really cool property where if you have a number in the exponent, you can bring it down in front. So that's the key thing. This is why this whole trick of being able to pull this exponent down in front, that's why we like logs. That's why we teach logs, really. And that's what we're going to be using to solve some logs today. So we're going to work on collaboratives, unit 8. We're on this one. So bust out, oops. A little bit touchy today. Not touchy every day, it feels like. Not responding. You're not responding, right? Try again. All right. Well, grab your sheets. Maybe we'll do it on paper. So we have our properties of logs. And remember, the trick with logs is remembering that, and I like to move this around personally. So I like to think of it really being more like x equals log of your base to your answer. So this is the same thing as y equals e to the x power. So this is how you get back and forth between the two. You remember that y is kind of like your answer. I call it my answer. If anybody has a better option for it, then let me know. I call it my answer. E is my base, right? The thing you're sitting on, and then you're raising it to the exponent. X is the exponent. So if you look at the log, x is your exponent, where you have the log of the base of the y. So this is my exponent. We'll do it up here. This is the exponent. Okay. This is my base. And orange maybe? That's my, kind of like my answer. I call it the answer. Because it's what you get when you switch them around. Right? Your answer equals your base raised to the x power. Are those too close together? So that's kind of how I like to think about it. And once you kind of wrap your head around that, whenever I see a log, I have to go through that to say, okay, this is my base, this is the answer, that's the exponent. Right? I have to kind of work through that and say, okay, that's the base, that's the answer, that's the exponent. So b to the 1, oh, b to the 1 should definitely be b. Right? B to the 0, that gives me 1. So anytime you see something, any base of 1, we call this log base b of 1. And if it's anything ever of 1, if 1 is your answer, then your exponent has to be 0. Because anything to the 0 power is 1. This one, my base is b, my answer is b to the r. So that has to be, r has to be my exponent. And I guess that's kind of a simple version, but like where it might come in, what might be like if you had log 4 of the 4 to the 6th, that would have to equal what? So 4 to the what power gives me 4 to the 6th? 6. Does that what makes sense for folks?
No.
Right? What this is saying is 4 to the what power, what goes there, gives me 4 to the 6th. Well, obviously that's going to be 6, so this is 6.
Oh.
It's right. We're not. It's not foolish. We're not trying to trick you or anything. It's pretty straightforward. Good. This one here is saying, oh, that's the opposite around. So this is saying, if I put this around and my base is b, my exponent is, so this is my base, this is my exponent. Oh wait, that's not, that's my answer. This is my exponent. This is my answer. So if I rewrote this as a log, so is everyone understanding, is everyone with me so far? This is my base, right? So what's the difference between these two? This is a log function. Does anyone see that? It says log in it. This is an exponent. We have something raised to a power equals something. So this is my base. This is my exponent. This whole bit is my exponent. That's my answer. So if I rewrote that as a log, I'd have a log with this base and that answer. Right? So let's see. Log.
So the exponent is the whole thing, log b.
Yeah,
X.
the exponent is that whole thing.
Oh, yeah.
So I'd say log. And then what's my base? B.
B.
Everybody with me? And then what's my answer?
X.
X equals my exponent. What's the exponent? Log B of x. And what do you know? They're the exact same thing. So, is everyone understanding me? If I rewrote this in log form, I'd have log of b base of my answer equals my exponent. And that makes sense because they are exactly the same thing. Right? Log base b of x, log base b of x. So where this is useful, why do we do this? Is so that we know that if we raise b to the log of that base of something, I just get that same thing. So these two cancel each other out. So that's kind of where this comes in useful. Is what we know is from this, what we take from this, is that these two parts cancel each other out and they just give me x. These two parts just cancel out and they just give me r, or whatever that is. So that's we can use that tool. If we have this and want just that, we can just do log of this base, and that will just give us what's up there. Or if we want, if we have something where we have log b of x and we don't know what x is, we can just raise both of them. We can put b to that power, and we'll know we'll get that. So it comes in handy, which we'll see as we work through some problems. The other one, like I said, which is super, super, super cool, is if I have a log, like say log, I'm just going to leave it as regular log of 5 to the x. That's the same thing as moving that x down in front. X times log 5. And we'll be using that a lot. It's that nifty trick saying that if you have this, you have an exponent. If you're taking a log of something with an exponent, and that you can take that exponent and just move it in front instead. It's the same thing. And we just proved that twice. So remember that a minute ago? I'm getting quiet looks from folks. Remember, we just proved that we can do that. Right? We did that twice. We did it with log and proved that they're the same.
Okay.
Sorry, that's 90. I misread that one. 903. Right? And we did it with natural logs as well. And we proved that they end up being the same thing. Okay. Great. So now we're going to, I'll show, I did one earlier. Do you want me to do this one again? Only using natural logs? Would that be a helpful review for folks, or are people kind of okay without this? I'm sorry, was that a yes, no? Yes. Yes, review it? Okay. All right. So I did the left one last time. We'll do the right one this time. Okay. So what we have is we have 2 to the x minus 1 equals 5. I don't know how to solve stuff that have an x in the exponent. So instead I'm going to take the natural log of both sides. So I'm going to do ln of 2 to the x minus 1. And that's equal to natural log of 5. You have to take natural log of both sides, not just one or the other. Whatever you do to one side, you got to do the other side. So let me draw my line for success here. All right, and what that lets me do is use my nifty property of taking the x minus 1, move that in front. So now I have x minus 1, and leave it in, if it's more than just x, put parentheses around it so that you don't end up being just x minus, and that way you don't just multiply the negative 1 times the natural log of 2, you multiply all of it, like you should. Natural log of 2 equals natural log of 5. All right, so this whole piece, x minus 1 times natural log of 2 and natural log of 5. My strong suggestion is, so you don't end up messing yourselves up and getting lost with numbers, is just find natural log of 2, find natural log of 5, and pop them in. All right, so what's the natural log of 2? I think we found it earlier. That was, everyone find natural log of 5. Natural log of 2 was 0.301, I believe. Oh no, natural log. That was the weird one. That was, oh, we didn't find it. Okay, everyone find natural log of 2 and find natural log of 5. Natural log of 2 is 0.6931. David, find natural log of 5 for me.
.698.
698.
I got 1.609.
Natural log.
Oh,
1.6.
This is on the wrong one.
Yeah, natural log of 5.
okay.
Did you do it?
I don't think that's on my calculator.
It's natural log.
Ln.
LN? Do you have an LN?
Oh, yes, I think so.
There you go. Do you get 1.609?
Yes, that's what I got.
Okay. And then we're going to divide both sides by, do this in the later stuff. Divide both sides by 0.6931. So then on the right, I'll have x minus 1. And that's going to equal, what's 1.6094 divided by 0.6931? I get 2.322.
Yeah.
And then I just have to, what's my last step? Oh, so here, is there anything acting on these parentheses, anything, am I raising it to a power or multiplying something in front of it?
No.
Nope, so now I can take them away.
Yeah.
So that's x minus 1 equals 2.322. So now I can add 1 to both sides, right? And we'll end up with x equals 3.322. Done. And that's what they got too. They did it in a more complicated way. I would not suggest doing it this way, because when people start dividing these things, it gets messy, and people do strange things with it. So I would just find them and then divide them, because you're all comfortable with numbers. Let's just not complicate things. Okay. All right, so now we're going to use logs. To solve these ones. So I'm going to let you folks work on I'll tell you what, I'll do number 3. And I'll let you folks do number 1 and number 2 and number 4 on your own. How's it sound?
Good.
So number 3, first I need to get the exponent by itself. Does everyone see that to be multiplied by 3?
Mm-hmm.
So I'm going to divide both sides by 3. And I'll get 4x equals 3. Good so far? Now I'm going to draw my line for success. Now I have the x and the exponent. I don't know how to solve that. The only way to solve that is to take the log of both sides. So I'm going to do log of here and log here. So I've got log of 4 to the x equals log of 3. Log of both sides, not just one, both of them. That lets me grab this fellow, throw him in front. So now I have 4 times log of 4 equals log of 3. Now I just have to find those two numbers.
Where did the X go?
Oh, x. Sorry, it's not a 4, it's an x. My bad. Thank you. All right, so I don't know why I had that. Okay, so x times log of 4 equals log of 3. So now I just need to figure out what log of 4 is. And log of 3. What log of 3 is. So log of 4. Log of 4. I get 0.602 as the log of 3. Give me at least 3 sig figs. 4 is probably better, but 3 is good. 0.477. Then I'm going to divide those. Right, I'm going to divide both sides by 0.602. And I will get x equals 0.793 if I round. Should round up. Okay, so you folks work on 1, 2, and 4.